Now that the CAM part is fully defined, we can begin adding the iMachining operations to machine this part. Now, as we go through the programming, take note of how the definitions that are required by the iMachining technology are quite minimal, and most of the guesswork that you might normally be accustomed to is eliminated when using iMachining. It's here that we'll be doing the absolute minimum needed to define the operations in this exercise. You'll see that the iMachining technology does the rest for you. So let's start off with adding that very first iMachining operation, and then we'll go from there. So for the second step, we'll begin by adding an iMachining operation to machine the outside contour. Operations can be added to your CAM part either by using the SolidWorks Command Manager or the SolidCAM Manager. In the SolidCAM Manager on the left, right-click Operations, Add Milling Operation, and select 2D iMachining. The iMachining operation dialog box is displayed. Now, the iMachining operation interface is designed so that you can easily define the rough, rest, or finish machining from within this dialog box. For the purpose of this exercise, we'll only define the rough and finish machining. So to start, we are going to use the default iRough technology. Under the Technology dropdown, you'll see that the Operation Parameters pages are presented in a tree structure, which is also the workflow that we should follow when defining our operations. This is the same type of workflow that is used by many of the other SolidCAM technologies, not just iMachining. So it's very easy to follow and very easy to use. First and foremost, we have to define the geometry. The geometry selection prompts iMachining what and where to machine. So on the Geometry page, click the New button to start the geometry definition. When defining geometries in iMachining, you're required to perform some chain picking. Now, SolidCAM offers several methods for chain picking to help facilitate the process, which I'll show you in just a minute. But one very important thing to keep in mind is that the geometry in iMachining is defined as a pocket that can be closed, open, or semi-open, which means containing open edges. Now, there can be many different configurations of pockets. A pocket can contain internal chains treated as islands or even used for safe tool entry. In any case, though, the geometry is defined in such a manner. For the first operation, the geometry is defined as an open pocket with island. You should also keep in mind that the chain selection order is important. In the SolidWorks graphics area, select the two chains as shown. We can close both chains by using the option of Auto Constant Z in the Geometry Edit dialog box. And when the confirmation messages OK to accept appear, click Yes to accept the chain selections. In the Chain List section, right-click the outer chain, or Chain 1, and choose Mark Chain as Open. This will enable the tool to approach from the outside and start machining from this chain. Now that we're finished, we can click OK to confirm the geometry selection. Next, we need to define the tool we'll be using to perform the machining. So move down to the Tool page and click the Select button to start the tool definition. Click the Add Milling Tool button and choose End Mill from the Milling Tools list. Under the Topology tab, define the tool parameters as follows. Set the diameter to 9 mm. Keep the default values for total length, outside holder length, shoulder length, and cutting length. Change the number of flutes to 4. Under the iData tab, we'll use the default 45 medium value for the helical angle parameter. Now, this parameter affects the cutting conditions and step-down values that are generated by the Technology Wizard. Click Select to confirm the tool definition and to choose the tool for the operation. Next, we'll define the milling levels. And to do that, we first have to switch to, of course, the Levels page. Click the upper level button to define at what Z level to start the machining. Pick on the top face of the stock model. Click OK to confirm the selection. Next, click the Pocket Depth button to define the machining depth. Pick on the bottom edge of the target model like so. Then, click OK to confirm the selection. In addition to the picked depths, you can also define a delta depth to perform machining deeper than the part bottom edge. For example, let's set the value to negative 0.76 millimeters. Now, let's switch to the Technology Wizard page. This wizard automatically calculates the cutting conditions for the iMachining technology, taking into account the tool data and milling levels that are defined for the operation. For this operation, we'll simply use the default cutting conditions generated by the wizard based on a machining level aggressiveness of 3. Moving down to the Technology page, we'll leave the wall island offset at 0.24 millimeters. At this point, the operation definition is completed. So all we really had to do was define the geometry, the tool, and the milling levels. Based on those definitions alone, the iMachining technology does the rest. Now, just to kind of keep things organized, let's name this operation iRough Outside Contour. Click Save and Calculate to add this operation to the CAM tray and calculate the iMachining toolpath. Then go ahead and click Simulate. When the simulation control panel appears, we'll run the operation simulation in HostCAD. Now, just to let you know, I'm using the Show Trail and Show Tool 3D options that we have in our HostCAD mode. Go ahead and start the simulation by clicking the Play button. We can see that the wireframe toolpath is displayed on our model. The entire contour is machined with a morphing spiral. Now, this is exactly what we're looking for in the iMachining toolpath based on the geometry being an open pocket with island. And once we're finished with the programming, we'll run the simulation in our Solid Verify mode. For now, we'll just run our simulations in the default HostCAD mode, taking a look at the wireframe toolpath. Close the simulation control panel with the Exit button. Now, from this operation, we can quickly create a finishing operation to remove the excess material from the outside contour. At the bottom right corner of the iMachining operation dialog box, click the Save and Copy button. The current operation closes and the copied one automatically opens. To have this operation perform the finishing, simply click the Technology drop-down and just choose iFinish from the list. The copied geometry, tool, and milling levels definitions from the previous iRough operation are used. The default Technology Wizard settings are also used. Now, I want to show you something on the Technology page. Under the Technology tab, the wall island offset value is now set to 0 by default and cannot be edited. Under the iRest Data tab, the previous iRough outside contour operation is selected as the parent operation, and the data needed for calculating rust material is input in the parameters fields automatically. Name this operation iFinish Outside Contour. Click Save and Calculate, and then click Simulate. When the simulation control panel appears, I would recommend first slowing the simulation speed down. Then, click the Play button. The finishing toolpath is performed in a single pass. Now, we can close the simulation control panel and the iMachining operation dialog box by using the Exit buttons. Well, that concludes Step 2, where we've defined the rough and finish machining of the outside contour using the iMachining technology. In the next step, I'll show you how to quickly and easily define the rough and finish machining of the center pocket.